Alright, so here's our next question. Slim needs to draw 2 diamonds in a row to win a poker hand. He looks around the table and notices that 4 of the 11 visible cards are diamonds. What's the probability that Slim will draw 2 diamonds out of the remaining cards, not visible? Okay, so the remaining cards that he can't see. Okay, so hopefully you're sort of familiar with how cards are, you know the suits and all. If not, sorry, on the test there shouldn't be any questions which really require you to know anything about cards, okay? And if there are, then I'll go ahead and explain them to you. Okay, now for this one though, he notices 4 of the 11 visible cards are diamonds. Okay, so let's think first on that. Okay, so 4 diamonds got used up already. So how many diamonds are left? Well, if 4 got used up, there should be 9 remaining. Okay, now if there are 9 remaining, how many cards total are remaining? Well, 11 cards are used, and so that leaves him with 41. Okay, so the probability that on his first draw he gets a diamond is, well, 9 diamonds out of 41 cards remaining. So we're really trying to find what's the probability the first one is a diamond and the second one is a diamond. Now that we know the first one was a diamond, let's say we got it. All of a sudden, instead of 9 diamonds left, now there's only going to be 8 diamonds left. Okay, so only 8 will remain. But it's no longer out of 41 because we just got one more card. So this one's going to be out of 40. Okay, and I'll let you multiply that out yourself if you're interested. Okay, it's always, like we said before, the top number is the number of successes or cards we're interested in. The bottom is the total possibilities. Okay, this one is number 57 from your chapter. And it's a good example of one of the ones where you need to understand your conditional probabilities. A lot of this, though, is just going to be plugging stuff straight into the formulas that we got. Okay, so what was that formula? It was this. Hopefully you have it from above. Probability of A and B equals the probability of B times the probability of A given B. Okay, or you can just say, look, here's how it goes. Okay, so whatever order you have up here, or the order that you have in the front, it's always one object, one event, then the other event, given that the first event happened. Okay, so on your right-hand side, it's always got to be opposites here, like B, A, B, something like that. Okay, so Functional Robotics Corporation buys electrical controllers from a Japanese supplier. The company's treasurer thinks that there's a 0.4 probability that the dollar will fall. Okay, in value against the Japanese yen next month. They also believe that if the dollar falls, or given that the dollar falls, there's a 0.8 probability that the supplier will demand renegotiation. Okay, so what's the probability that the dollar falls and the supplier demands renegotiation? Okay, well your answer, your answer is dependent on and. Dollar falls and demands renegotiation. Okay, so how do you know what's what? Well, you always, for this type of problem, and make a note of this, write this down in the margin, always look for where does it say if or where does it say given that. Okay, where does it say if? Where does it say given that? The treasurer also believes that if the dollar falls, they'll demand renegotiation. Okay, so let's say up here, A and B. So the probability of if the dollar falls, or given that the dollar falls, they want renegotiation. Okay, so R is renegotiation given that D, the dollar falls. Or if you want to match it up to the formula up top, that's the probability of A given B. Okay, so anyway, that's equal to the probability of A given B, or renegotiation given that the dollar falls, we said was equal to 0.8. Now we also said the other thing we need is just the probability of B, or just the probability the dollar falls. That's equal to 0.4. Okay, so we have two things. Probability of renegotiation given that the dollar falls is 0.8. Probability of the dollar falling is 0.4. Following our formula, the probability that both happen, or the probability of renegotiation, and the dollar falling. Sorry, I wrote the wrong thing there. And the dollar falling is equal to 0.8, and that's times 0.4, and that's equal to, I believe, 0.32. There you go. Okay, so that's a very straightforward application and plugging in of this this problem using that formula.